Listen to a lecture in a chemistry class.
Today I want to talk about crystallization, which is the process by which a liquid solution turns into a crystal. This is the process that is responsible for creating the beautiful gemstones that we see in jewelry stores and stalactites that hang from caves. Just so you know, this lecture is going to be pretty term-heavy, so if you all need some more explanation about anything, please let me know and I'll try to explain until everything is crystal clear. Okay, so there are actually a couple of steps in the process that create these pretty crystals. The first is called nucleation. During nucleation, small particles in solution start to accumulate in little clusters. The solution, of course, is a mixture of two or more substances. The clusters can stabilize in the solution and will eventually form the nucleus of the crystal. If they don't stabilize, however, the particles in the solution just dissolve once again. And I want you to understand that the stability of the clusters is completely dependent on factors such as saturation levels and even temperature. When a solution is supersaturated, it means that it contains more particles than can be dissolved. Do you all get that? Typically, supersaturated solutions are more likely to support a stable cluster that can form crystals. Meanwhile, temperature can affect saturation levels by triggering evaporation or vaporization of the solution. So both of these conditions are very important in the growth of the crystal. Anyway, once the nucleus is formed, the atoms of the solution begin to form around it. The pattern in which the atoms form is called the crystal structure. Just so we're all on the same page, I want to emphasize that the crystal structure I refer to here does not reflect the shape of the crystal once it has fully developed. Instead, the crystal structure really just describes the pattern in which the atoms are initially formed. And that's the nucleation stage. The next stage is when crystal growth occurs, and as you can guess, it mostly entails the maturation of the crystal. I want to point out that nucleation and crystallization often occur at the same time. That's why, if you've ever seen a crystal, you'll note that there are usually different shapes and sizes of crystals. So, does the crystal growth just go on, or does it stop eventually? I'm sure you can guess that there is an end to crystal growth. It sort of has to do with the same conditions that either promote or stop growth: temperature and saturation levels. See, when the solution is no longer supersaturated, either because it has been exhausted by the growth of the crystal or because other changes have occurred, the crystal pretty much stops growing. What's interesting, though, is that you can supersaturate the solution to start the crystal growing again.
7. What is the main topic of the lecture? 8. Listen again to part of the lecture, then answer the question.
This is the process that is responsible for creating the beautiful gemstones that we see in jewelry stores and stalactites that hang from caves. Just so you know, this lecture is going to be pretty term-heavy, so if you all need some more explanation about anything, please let me know and I'll try to explain until everything is crystal clear.
Why does the professor say this?
So if you all need some more explanation about anything, please let me know and I'll try to explain until everything is crystal clear.
9. What is the professor's attitude toward crystals? 10. What happens if particle clusters do not stabilize? 11. How is the discussion organized? 12. Based on information from the lecture, indicate which of the following statements reflect the process of crystallization. Place a check mark in the correct box.